So, I thought I'd show you my flow for the load load limiter regarding the charging of the electric vehicle. I have a Zaptec charging unit, but it should be the same principle for most. I have a Kia e-Niro with the car, um, but it doesn't really matter in this sample. And also I have three-phase charging, maximum of 11 kilowatts, and I have 16 amp fuses for the house. So I thought I'd show you the for the car. What I have here is this is for the car, and I have here set up a virtual device called Power, and here I set the maximum power that I want the Zaptec to limit to. So if I set it to 12, then I get here 12. This is this is the actual set limit. We'll come back to that. This is the requested limit, what I would want, and this is well the same or lower if the logic later on decides to set the limit lower than what I want. And then here's the Zaptec, and this has some properties, which is of course the important one is this is the same value as this one. So if I change this one to 10, also this one will be 10. And of course here you have the actual currents going out. Now it's idle, so it doesn't do anything. And you have the voltages. Of course now the voltages is disconnected, so the voltages are ambiguous. So they're not 230 volts, and they're also not zero. So um yeah, so that's about it. And then for the car I have some this is the state of charge for the car, and this is what I want maximum, and so on. Can show you quickly. I have also a functionality where two types of charging functionalities. I can mention those. One is when I set this, I say that when the price is lower than 6, it will charge always if connected. And this is the actual price. It's a bit silly. It's in degrees, kind of Celsius here, but there's no unitless virtual device. And those which are thermostats are very practical because you can use this dial. So I'm going to ask Atom if they can add a unitless device capability. It would be nice. And so I have this it always charged, and then I have this on and off. So this device will enable or disable this, and otherwise I have a time which I used before. I say this start charging at 11, for instance, and um, and then charge for 2 hours. And I have the same for tomorrow since I know the charge times. Or the prices also for tomorrow. I could set the price tomorrow, and then at 12 o'clock at night, tomorrow becomes today, and so that's two of the ways to start, and it runs up to maximum allowed state of charge in the car. So I will show you in another video exactly that how that works with the charging plan, so to speak. So anyway, so that's the background. So if I go to the flow, which regulate this, it's I call it the current tracker. So what I do here is normally when there's no charging, I do a check interval for the current. It's just for the getting some data, and I set if the charging if it's not charging, I check this. I do an average calculation of the current, and I do that every 33 33 minutes. And 33 is just that if you do this set every half hour, so then Homey will do everything every 30 minutes on the hour and half hour. And if you do it a bit odd, then you will have not interfering with other stuff it's doing. So not super important, but I try to distribute the load on the processor. So anyway, uh, and then when the car charging starts, I set this to 1 minute. So then I do a much tighter check interval. I just try to not check everything what I don't need to know all the time if it's not necessary. Just creating a lot of data. So that's why I changed the interval. You could also do switch this flow on when charging starts. Is also a method to. So I mean, it's just one way of changing the check interval. Um, and as I see, I do here is I use text variables to calculate the average for it, just to not have them in the insights, because I don't need to look at them in hindsight. So and it's because I showed you in some video where you can actually calculate with text variables if they are actual numbers. So it's the same here. Fuse amp is my maximum allowed fuse, set to 14 right now. 14. I'll show you first. I will show you this flow in reverse order because it just makes sense when you explain it. This is I calculate the charge current space. That's how much space is there for charging the car at every instant. That is, I have the fuse, which is 14. I've set it. This is set to 14. It could be 16. It's actually 16, but I set it to 14 just now. It doesn't matter. And what I do is I take the allowed amps current, and then I deduct the current for the whole house, which includes, of course, the car charging, and I deduct from that the car charging current, and then I get the potential car current. So if this is 14 and the current right now for the house is 10, and I charge the car with 6, then this part is 4, and this means that 4 is the load that the house draws. So then the allowed current for the car is 10. And I do this for all 3 phases. And then when I set a temporary variable to the minimum current charge, I call it current min, and then I set it to the first space, and then I check if that temporary variable is more than the second phase. If it is, that is limiting the the total current, and then I do the same for the third phase. And if that is also more than because I'm looking for the smallest value, so then it sets it to. So this is a way to compare the three phases with each other, because you only can compare them two by two in this logic. You could do, of course, a Homey script to compare all three of them, but well, if I did a Homey script, some of you wouldn't want to touch it, so I did it with the cards. So anyway, so what I do then, and this I do then every minute, but I also do this current averaging, which I do, as I said, perhaps with the I do a five period running average. I have the average. You see average here, multiply by 4, adding the current right now. This is for the whole house current, and then divide by 5, so I get a 5 minute rolling average. And then when I've checked all of those, I do the same calculation as before. I showed you fuses, but now I compare this. I use the same name here, charge current space, as I did on the temporary one, on the momentary check, because this is done in sequence. And then I do the same. I take the current and I take the car current and get some value. And well, this could be smaller or larger than what is going on exactly right now. I mean, just if you, for instance, start the water boiler, it will draw 10 amps. So, but for a very short while. So, for instance, so it's, yeah, and you can overload the fuses quite much for short bursts, but in the long term, you don't want it to, because it will burn the fuses eventually, wear them down. and then and then when I have this value, I get the current charge average minimum, same way as before. Just compare the three phases. I'll go on and do the same check, but now I do it for as I showed you earlier, but for this moment. And then when both are these are calculated, I check if the average or the temporary or the momentary charge minimum is, which one is less space for charging. And then I set I choose the lowest one of these and set a variable to that name, charge current new. That is the new current I want to set. And I check this current new against the existing current limit set in the Zaptec. And of course, if it's lower, I will have to reduce the allowed current. And then I do set a new variable, Zaptec request current, a logic variable I made. I set this to the charge current new, and if it's higher, that is, I have more leverage. I have set a factor of 2, so and that is just if I get higher value, it will lower, but for it to rise again, it will have to be more than 2 higher than the current, just not to make it jump up and down so much. You can maybe I'll add some kind of timer on this or something later on. I haven't tried it so much yet because it's only winter time. Mostly it will be. Well, actually, I could set the, but it's anyway. It's I haven't tested this, but this is the principle. But of course, you could set some kind of timer that if the time is less than something, uh, then that is hold the current limit for some time. For instance, it would be quite easy, especially going up again. You might want to go down, of course. And this is what I showed you before. This is the power setting I made. If the charge count new is less than the target I want, then it will calculate the request current as charge current new. Then we'll set the new current. But if it's more than, if I've set 14 and if I've set 10 as maximum current I want, and it sees that the space is actually 12, it will not set 12. It will set only 10. So that's the limiter. And of course, it ends with setting the available current on the Zaptec, the actual Zaptec parameter, one for each phase 1, phase 2. And then I set the actual current request in the same as the measured temperature in this gauge where I had the power setting. And so this is kind of a first basic approach to doing this. So we'll see if we can fiddle about maybe with some. If it jumps up and down very much in power, you can argue maybe to set some kind of dampening in the form of a timer that allows some overcurrent for some time and some undercurrent for some time, and then this is just a basic approach. So we might do if I do a test run here, we can see what happens. And so what happens here, we have the current right now is 2.1, average before is 0.7, so we get a new average here, which is 1, obviously. Current is 0 for the right now for the car charging, because car's not charging. 14 is the limit, so 14 months, so we get 13. So if we look at this, I get 13 amps, 13.52, 13.22. So it has set, actually 13.02 was the least one. Yeah. And then for this one up here, same thing. So I reuse this charge current space as I did in the first part of, because I don't need it when I've done the charge current min. Then it's just a hold parameter. So we do the same here. Fuse amp 14, current amp for the house 0.3, of course 0 as before. I get some value, 1307, 1372, 1192, and you see this will be 1192. So obviously 1192 is less than 1302. Oh, this won't show. This one, 1192 is less than. And then it will go on. It will set 1192 is less than 10. No, it's not. So we get this one, 1192 is less than 10. No, so no action. Um, yeah, otherwise it will, of course, go on over here. So that's the well, fairly simple approach to the whole thing. Then there's actually for the Zaptec box there is a parameter saying that when the current goes below some number you can set for yourself, it will switch to one phase charging. And I think this is actually the car, the charger, the the rectifier in the car or the OBC onboard charger unit in the car that doesn't want to charge with too little current because it's not effective or something. And then the Zaptec would switch to one phase charging only. I tried this and it hasn't happened, so I don't understand that. So that's and there's no way of controlling that parameter from the Zaptec. So from the Homey. So I don't really know because you can't have two different systems deciding on the same subject. That will cause mayhem and chaos, of course. Maybe not mayhem, but it will cause confusion. So, but on the other hand, because I have my one of my fuses, which is quite normal in most households, is that you have one fuse that is much less loaded than or the other two. Um, and we had a one phase charging car before, and then it was more important because so actually my phase 3 from the grid is phase 1 in the box, which also is haven't really figured out yet. So anyway, and another thing, the current for the house I get from the home wizard, um, a home wizard unit which draws data from the power meter, um, the a yeah, directly as a data interface with some kind of module. And so here I have so that is um, that's the data for the unit or for the which I compare to the car amperage. And as you might see here, now it's very even. It's 0.4, so there's hardly any load at all right now. So that was it, I think. Yep. Thank you.